is how machines know. And we can have a philosophical discussion afterwards about the nature of knowing, if you will. I'm currently reading Karl Popper's Objective Knowledge, which I think gives a great perspective on this kind of thing. But I'm going to focus in on this idea of data giving us things to know. Because the big question there is, how does it give us things to know? Does it magically just go straight into a mind of some variety? You know, data becomes knowledge just by osmosis or something. Or is there another route through this, through derived information, through some kind of contextualizing narrative or feature engineering if you're talking to machine learning? So in this short talk, I'm going to talk about the stories we tell with data. I'm going to talk about the stories that we tell about data. And right now, how we're telling these stories to machines in different ways. Excuse me. So starting off with the stories we tell with data. So some of these are stories that in my role I tell, you know, from a Microsoft perspective, but they also think about the way we tell stories. We heard from a data journalist earlier, and I think that gave a very specific picture of how we tell stories with data. But I come from industry, and so these are the ways that I talk with data, in some ways, to get people to use our tools. So let's take this example of a piece of data. This is a satellite image of a river delta before illegal small-scale mining has taken hold. This image is a piece of data. Similarly, this image is after illegal small-scale mining has taken hold. Illegal small-scale mining has an impact on ecology, on society, because along with illegal mining comes illegal jobs, which are not, where people are not protected, and an impact on the environment. Using that data in new ways with new tools, Microsoft software engineer was able to use satellite imagery to detect the emergence of illegal small-scale mining faster than traditional methods. So traditional methods being boots on the ground, which is dirty, dangerous because they're illegal and they don't want to be found. So this is a way that data was used with modern tools to have an impact where we couldn't have impact before. So that's one side of a data story. On the other side, we can talk about money in industry, how much data can save us. In this example, this is a cruise ship. There aren't cruises happening at the moment, but this applies to any resource usage in where people are, whether that's buildings or those kind of things. And using advanced analytics techniques against data the organization already have, a huge saving was possible. Huge saving of money through efficiency. So this is another story that has data at the heart, but now we're talking about the value to a particular business. Jumping across, I talked about new tools, and because I work for Microsoft, here are some Microsoft tools. We call these the cognitive services, and they are pre-built models. So we've taken the data, we've done the machine learning, we present these models as APIs for people to use as a service, so a kind of cost per call model. And you can see here everything from vision to the custom vision service, which could be used for detecting illegal small-scale mining, through speaker recognition, speech recognition, facial recognition, all the way through to search APIs that help you gather data sets of data from the web. But I'm going to talk about this one, text analytics. It's one of my favorite ones because it kind of sits there innocuously in the middle, but has a huge amount of investment behind it at the moment. So we take a piece of text on the left here. This is actually a Shakespeare sonnet. This is being treated as a piece of data. And then the API gives you a language score. It gives you key phrases, sentiment, talks about the named entities. We were talking about ontologies before. It's trying to extract some kind of ontological understanding from this text. And you can see here, it's calling SAP, as the sonnet talks about from a flower, as an organization, because it has a very specific ontology of the world that's built from a business perspective. Linked entities, you know, it's pulled out an idea of a flower in there. I took this a step further because I was fascinated by some work by Franco Moretti, who's a literature professor who talks about this thing called distant reading. The idea that you, as a literature person who studies literature, you read very closely a lot of the time. You read one or two books in great depth, and your experience is from reading at that depth, as opposed to using modern tools to take a step back, treat the books as data, and start to look at them en masse in a sort of horizontal fashion as opposed to a depth fashion. And I found out that the complete works of Shakespeare are available as a 5 meg text file for download. That's great, lump of data there. And I thought, let's see what would happen. So to do that, I did the processing. The hard piece was processing the text into some kind of data that could go through the API. Shakespeare didn't write his plays for data analysis. I mean, it's short-sighted of him, but we'll forgive him that, and I'll give him that feedback. So once I'd done that, I had a data set and I had to show it in some way. So what I decided to do, and by the way, I know we've got a very mixed audience. There are spoilers for the plays here, so if you haven't read them, please forgive me there. So here we see a visualization of Romeo and Juliet. Now, along the bottom, I've created a timeline because Shakespeare usefully wrote in 5 acts. And so it's act.scene as the timeline along the bottom axis. And then the y-axis, the vertical axis, is net gain or loss in sentiment of character speech. So the things that are being said by the characters at each point in the play. And what we can see here over time, and time as the course of the play plays out, is the narrative structure of Romeo and Juliet when it comes to spoken sentiment. We can see a fight in the town square. We can see a love story with twists in there. And we can see that the play results in tragedy. Now, a build-up of happy emotion and then a teardown. But overall, the play is considered from this perspective as positive. We can look at individual characters and we can see that Romeo is more extreme in the sentiment of what he says in the play compared to Juliet, who roughly maps to his sentiment, whereas the nurse is continually positive. If we jump to the Scottish play, we can see how different characters are used to change the way the sentiment of the story. The wives in Macbeth are used to turn from positive and vain male hope through to the realities of murder and political struggles in the Scottish court. And we can also see in here the difference in sentiment when people are talking about murdering versus killing. When you're hiring a murderer, you're generally more positive than you are when you're resolving, talking about villainy and these kind of pieces. So this is a mixture of the tools that process the data we have in different ways, but then telling the story of what happened using visualizations of that data. So I'm telling a story about a story here, if you will. And if we think about the other cultural assets that we have available, you can look at this kind of storytelling. And this is storytelling from data with a sort of exploration flavor. The Met Museum used our tools to create a new online experience around the art assets that are available as pictures. Now, the conflict here, and I think this speaks to this idea of data producers and consumers that was mentioned in the lightning talks earlier, you have the curators who hand curate a set of data, and for good reason, are very precious about that. They are experts, and their data should be treated in a special way. You then have the tags sitting down here on the side. These are generated by artificial intelligence tools, visual tools, and visually similar art is also done with vision algorithms. And they had to be kept separate. They're not being talked about as about it, they're talked about as tags and these pieces. And so the presentation of these assets with the metadata that's generated has a particular story around it, and the way that that data is used in that particular industry has to be handled very differently. So here you can see the stories we tell with data. Data is part of the work that's happening. The second part is the stories we tell about data as a thing in its own right. The data is not part of looking at Shakespeare. This is what data is to the industry. And in my current work, an image and animation I use a lot is this one. This is known as the digital feedback loop. This is part of the digital transformation story. You're either going through digital transformation or you're expecting to shortly in business, and it's an exciting thing to do. And when you look at the different pillars of this, you have your customers and employees and products, and you're looking for these signals from data to allow you to have this beating heart of analytics and intelligence at the minute. So this is non-specific. This is not talking about one particular organization. This is talking about data as an asset. We're talking about the data itself here. We also talk about the journey of how industry has used data that leads to this advancement, the innovation. Software itself was written initially, in the lion's tea house to process data. And software was an automation of a manual data task. And then what we learned to do on the top of that was to produce more data from the software to be analyzed by more pieces of software and more people in this way. And the reason we did that is because the task of processing payroll at Lions was need to be done more quickly. So it's a massive business that was having to handle this ERP scenario. But then we could start to use that data through analytics to help people make decisions. It wasn't just the task that needed to be completed so people got paid. You could start to understand a bit more. And so data became this asset to human learning in business, which would drive action that would help you make changes. The most recent sort of boom in storytelling about data itself was big data. I mean, AI has kind of muddied the water a bit here, but big data was the thing that unlocked that. I don't like the term personally, because for me as a, working in data, it was just about there being more data available. Big data was just the data you couldn't handle yet. And it fed into that analytics process. You had your Hadoop cluster because you wanted to process it quicker, so you could do more analytics and make better decisions. Then came along this idea of automation from learning from data. And as Nick said at the start, I've got a Bachelor of Arts degree in artificial intelligence from Sussex. And, added some Japanese on there as language, culture and society as well, because we didn't quite have access to the tooling and the data sets to be able to make the algorithms do what they promised at that time. So I went off into the wilderness of being a data technology startup CTO and all that kind of stuff. But AI has come back to me in recent years. This idea of machine learning and creating a new piece of software. Yeah, you can talk about it as a model, as something separate, but it still has inputs, processes, and outputs. It's still something that is used as software to inform that action. So on the one hand, you're talking about software-derived data, and on the other hand, you're talking about data-derived software. Again, it's a story about data. AI sits there on the end. Human intelligence can be judged based on the intelligence, the perceived intelligence of the action, and artificial intelligence can be judged based on the perceived intelligence of that software taking action for you. But then what happened is we started to have this new conversation about data and AI, about the ethics of data and artificial intelligence. And these are Microsoft's principles. You can read more about our journey in the future computed, free ebook there for download, and fairness, reliability, and safety, all the way through to this idea of transparency. We heard in one of the lightning talks about how new tools can be used for the interpretation of models. But one of the stories that really stood out to me when I was doing this was this story of fairness, how AI systems should treat all people fairly. And the idea that bias that's built into that data somehow from the way we collect it, and this idea that data doesn't represent the world purely, it represents the world as lived in and dealt with by human beings. If we build our machines based on that data, they capture that bias and they use it. And you can find examples of stories about the use of data here. So this is Durham Constabulary using an algorithm built off data that included postcode as a predictive factor, being accused of bias, and rightly so, because postcode contains implications, very direct implications of socio-demographic status. And you have to remember at this point that people live in that data. An example here of how that breaks down, the pure data set there, a machine wouldn't even necessarily have those column headings to use in any meaningful manner. It has these bits of data that are representative of other things of people's lives. And there can be direct indicators of ethnicity and socio-demographic status, all the way through to real-world bias, where in this case, ethnicity wasn't applicable which is never the case. So the structure of the way that data was captured means that there's real world bias built into it at that point. And you start to ask questions about how can we make this more representative of what we're trying to achieve in a pure sense. And you go, well, actually, this is a study about the access to services. And we can start to abstract away that direct relationship to socio-demographic information. And here we boiled it right down to nearest hospital. And then you give this to the machines, because then it's studying access to services as opposed to interpreting postcodes in some way. Now, there's an argument raging here about the idea that if you're doing this, you're adding some kind of human interpretation onto the top, and that's bad. The new radical empiricists want everything to come from the data only. You know, any human touching it is bad. But we know that the data is not pure. We can tell stories about the process of that data and why it has challenges to help us see where we need to intervene. And this is especially true when we start to think about the stories that we tell the machines, because pure, even in its purest form, while data is flawed, it doesn't really contain this idea of the story. We can extract stories from it that we have to interpret, we have through visualizations, and there's a very human process there. But what we tend to do is to nullify this story when we're doing the work with data. We think we need to take out a lot of those pieces. So you have the machine learning on that data, and it takes an input and it makes a decision. We have this feature engineering part of the journey, and there is a story discussion at the start. We're discussing what we're trying to achieve. There is a human level discussion there. The process of machine learning is meant to nullify that story. So we have this story-free system at the end that's taking action in this pure way. But then what we do is we come back again, as we've seen, and we describe the whole thing with a story. And we're starting as an industry to talk about who's accountable for different parts of this story and why was a particular decision made and what place does the algorithm or the model that resulted from the work play in that overall story? What responsibility does it have? And so we have this confused process of nullifying stories and then making up new stories about the process that we're doing. And I've had the privilege to be sent and read two very interesting papers in this space. And I noticed that Nicola Strong is asking questions actively in the different sessions. And one of the paper was written by Nicola and others about this idea of how we put stories into that AI development. But the thing I want to call out here is this is talking about stories as data. And that's very important to consider the stories as data in the part of in the training part of building these intelligent algorithms. The paper on the other side of the screen talks about stories as systems, where we're trying to build in the extraction and development of this systems understanding of how the system in which the agent is working. And that distinction was really important to me when I was doing the research to what I'm presenting you here. And the reason it's important is because of the evolution of my work that I talked about before, from being a data and AI person to being an autonomous AI person who works in simulation-based reinforcement learning. Because we describe our systems as well as our data sets with stories, and then we back up those stories with data. So this is a sort of made up example of a systems dynamics model about how products interact with their environment. And this is a model that I've interpreted and I've drawn. But what I've then looked to do was to gather data to prove out whether and I'll use a controversial word here, but whether the causality that the system diagram requires to be true is in any way backed up and relatable with data. So, you know, I'm not allowed to say data something causation. It has to be a correlation. But then as a group, as a set of people, we have to interpret that as a way, as something we can intervene in. It is not inert. If I'm going to make an investment in, let's say, training school leavers to be part of this production process, I have to think about the causation of that because I'm investing for a reason. So the data backs me up, but I'm the one who's taken responsibility for that causation. And, reading Judea Pearl's work, there's some fascinating work there on trying to mathematize this idea of causation, kind of getting the maths to catch up with things we do automatically as people when we're telling stories and we're working in this way. And you can also look at the work on cybernetics. Cybernetics is a somewhat forgotten area of the wider AI space. But when you look at that model that cybernetics uses of sensors, algorithms, or schemata, through to actuators, you have to ask, why is it talking about algorithms and schemata as, oh, I've got a rogue apostrophe in there. I'll apologize before somebody comments on it. That shouldn't be there in algorithms. So these algorithms, we're working with a lot these days. We're talking a lot about algorithms. But where are the schemata? And if you look into cybernetics, this idea of a model of the world that is being used, this systems model, as it were. You remember the two papers there. Data processed through algorithms, stories as data processed through algorithms to create that machine learned agent, or this idea of building data into some kind of model of the world, some kind of system. I think there's an interesting split there. Now, if we take that cybernetic view of the world, that way of telling stories about control, we can look at reinforcement learning in this way. And there's a strong similarity between the agent having sensors and reading the state of the world through those sensors to decide what to do in that environment. There's a very strong link here between those two things. Reinforcement learning is very strongly tied to this idea of a system that the agent is working in. And this is where the idea of machine teaching comes from. And we have educators on the call. So I'm not going to dwell too much on the nature of teaching here, but this idea of setting up the curriculum in which that agent learns and taking the best out of what humans do to tell stories and to teach, and to build that into the way that machines can develop these models of the world, as opposed to just process data with algorithms. Now, just before this, I wanted to add in this paper that I was reading, because playing games is a big part of reinforcement learning, because they provide a controlled environment in some way. The work that I'll be doing next is very focused on the industry applicability of that. But this paper is particularly interesting because it kind of takes natural language as part of the input space for what is a data-driven piece of reinforcement learning. So the neural network at the heart here is taking in human readable statements, i.e. a story, these discrete events that were mentioned before over time, in an order 1 through 7. If you think about the Shakespeare example, I generated this timeline. We could do the same thing with the sequence of events here. Then the agent is trained, and the challenging space of reward shaping is controlled by adding in rewards based on these stories that are being built into the data space. So this swings the story back towards data. But to do this, to write that story, you have to have a schematic, this model of the world, to be able to do that. So here are some examples going back to what Microsoft is up to in this space. Hopefully that's interesting to some. We have this gaming capability, so the ability to generate as realistic worlds as possible to train agencies is something where we can cross over those different parts of our business. And there's on the bottom right-hand side, this idea of physical control spaces where control is happening, where that necessity for the acceptance of causation happens. And the experts in that space, they tell stories to each other. It's not just about tuning particular controllers in a particular way. When you get to that expert level, the expert has a story in their head. And the process of machine teaching is about capturing that story in some programmatic way to make it able to be used in these advanced forms of AI and reinforcement learning through simulation. So what does that mean at the end of the day as I draw this to a close? All of these stories we talk about are describing a system. Some of that data is about the system. Some of the data fits the story and doesn't. And we have, I imagine, many scientists on the call who are trained in working out how to prove or not disprove that data fits a particular story that they came up with. And the process of data is a different story, because you have to tell that story to build the credibility. And in some ways, you can talk about simulation as a way of discovering stories that people haven't told yet. If we think about AlphaGo, it created a new story in the space of playing Go because it did something novel. It discovered a new story to tell about that game. The next wave of AI is about how we're describing these high-level systems and how we're going to tell these stories to machines. But what do I think you can do right now? And I think many of the people we've seen are doing this, which is awesome. Look at how you're telling stories about the system now, and understanding where data fits into that story is key. It's not about rejecting the story and saying it's only data. And then you look for new tools to use against the data you already had, like Franco Moretti, like I was looking at with Shakespeare, to tell new stories about these systems and to look for those new patterns. So I think this is the opportunity we have to separate out using data to tell stories about data, and then to move on to think about how we tell stories to the machines to help it essentially empower everybody to reach new heights of human flourishing. Thank you.